Hello, welcome to Chapter 6. Today we'll be working on rational expressions and equations. So rational, this should be your tip off here. The fact that it has the word ratio in it. A rational function is anything that can be expressed as a ratio. That's it. So simplify each fraction below. 75 over 100. Now all this is finding the largest common denominator that will come out of each of these things. 25 will come out of both of these. 75 divided by 25 is 3. We know that 3 is prime, so it's not going to get any smaller than that. And 100 divided by 25 is 4. 210 and 315. Now, if you want, you can just start by dividing by things you know it will divide by. So 210 divided by 5 will give you 42, and 315 divided by 5 will give you 63. So you get 42 over 63. Now, try to find if there's any other number that both of these will divide by again, and you can reduce it even further. And it turns out that number is 7. 42 divided by 7 is 6. And 63 divided by 7 is 9. And then you notice that, again, you can find a common factor from these two. They both divide by 3. So 6 divided by 3 is 2. And 9 divided by 3 is 3. So 210 is 2/3 of 315. Okay? And of course, 105 would have been the biggest factor you could have removed right from the start, which is the product of all three factors that we removed. 5 times 7 times 3 equals 105, of course. So there you go. 462 over 693. 4 and 6 is 10 and 2 is 12. Since the sum of the digits is divisible by 3, so is the entire number. This one is as well. So let's try that. 462 divided by 3 equals 154. So 154. And 693 divided by 3 equals 231. You can keep trying. They won't divide by 3 again. They don't divide by 2. So they won't divide by any even number. They don't divide by 5. You could try 7. You could try a couple other primes. 154 divided by 7, 22. 231 divided by 7 is 33. Okay, so what was that? 22. So divide them both by 7, you get 22 over 33. And of course, now it's obvious that there's another prime that will come out of this, and that is 11. And divide each of them by 11 and turn that into 2/3 as well. And of course, the factor that we took out was 3 times 7 times 11, which is 231 was the factor we took out. So each of these things divides by 231. Factor each of the following polynomials completely. So again, greatest common factor. You're going to be able to take a 5 out of each of these, and you're going to be able to take an m out of each. You can't take more than one because this one only has 1. So 5m times m squared minus 25, and that's it. B, you can't take out a coefficient. Nothing is common, but this is a perfect square, and this is a perfect square, and this is a difference. So we have a difference of squares. So you can take the square root of each, write it as 3a minus 2b times 3a plus 2b. Consult your factoring flowchart. This one, you can do your sum and product. Two things that multiply together to give you 81 are 9 and 9. Okay, and the fact that this is negative means it's negative 9 and negative 9. X minus 9 times x minus 9. This is all review, so I'm going to go through it really quickly. 7w squared minus 14w minus 56. Well, first take out your GCF, which is a 7. That will leave you with w squared minus 2w minus 8. And then factor this using your sum and product method. So what multiplies together to give you negative 8 and adds up to negative 2? And the answer is negative 4 and positive 2. So w minus 4 times w plus 2. And you're done. Alright, rational expressions. Pause it, give it a read. This is what we're going to be doing today. Read your textbook, fill in the blanks, and then once you're done that, unpause, come down to the next section, and we'll work through these together. Expressions like 4 and negative 4, x minus 6 and 6 minus x, 2a plus 5 and negative 2a minus 5, they're opposites of each other. So what happens when you divide an expression by its opposite? Well, let's find out. 4 divided by 4 is 1, and it has a negative sign out front, so you get negative 1 in this case. X minus 6 over 6 minus x. This can be rewritten as x minus 6 over the negative version of, and you take out a negative, and the 6 turns negative and the x turns positive, so the negative version of x minus 6. And again, something divided by itself is 1, but the negative hangs out there, and you get negative 1. 2a plus 5 over, take out a negative, and that bottom one becomes 2a plus 5. Again, those canceled to 1, the negative hangs out, and your answer for all three then is negative 1. Interesting. Maybe, maybe not. For each rational expression, determine all non-permissible values. Now, non-permissible value comes about because the denominator cannot be 0. Okay? We are not allowed to divide by 0 because it just doesn't make sense. So, we have 3 variables in here. If s is a 0, then this whole thing is divided by 0. So s cannot be 0. If r is a 0, then r squared is 0, and this whole thing tries to be divided by 0, and that's not allowed, so r can also not be 0. Now it's actually okay for t to be 0, because 0 divided by something is fine. It's like if you have 0 chocolate bars to divide amongst 10 people, they get 0 chocolate each. But if you have 10 chocolate bars to divide by 0 people, well, there's no way to calculate how much chocolate each person gets if there's no people. Kind of a stupid example, but whatever, you get it. Alright. Now, the best way to find the non-permissible values is just to take the denominator. We don't have to worry about the numerator at all. Take the denominator and set it not equal to 0. So it cannot equal 0. So what are the values of x that would make this thing 0? Those are the values that we're not allowed to have because you cannot divide by 0. So if x is 0 here, this whole thing is 0 because it's 0 times both of these. So your first non-permissible value is x cannot be 0. Your second non-permissible value is 2x minus 3 cannot be 0. And then solve it. 2x cannot be 3. Divide by 2, and x cannot be 3 halves. Okay? The last one, just factor it like usual. p squared minus p minus 12 cannot be 0. And you factor this thing, so minus 4 plus 3, p minus 4 times p plus 3 cannot be 0. And then of course p cannot be 4 and p cannot be minus 3. Okay. Let's go ahead and do the your turn, hit pause, finish up. The answers will be here when you get back. There you go. Simplify each rational expression. State the non-permissible values. Okay, simplifying involves basically factor everything. Okay? As much as you possibly can, just factor the crap out of everything. So the numerator, you can take out a common 3 and you'll be left with x minus 2. The denominator, we can't take out a 2, but we can factor this using our familiar method here. So the factors of 10 are 10 and 1 and 5 and 2. And it's going to be 5 and 2, and the 5 is going to go here, and the 2 is going to go here. And we need to end up with a positive x. So which one's going to be positive? This one's going to be positive. This one's going to be negative. And double check it just to make sure it actually works. 2x times x is 2x squared. Minus 4x plus 5x, which is plus 1x, and then minus 10. Okay, so it's perfect. It works out. And now we find that those two factors cancel off, and we can rewrite this expression simply as 3 over 2x plus 5. And we're done. This one, the numerator can't be factored, but the denominator is a difference of squares. So in the numerator we have 1 minus t, and in the denominator we have t minus 1 times t plus 1. Now these can't cancel each other off the way they are because they're opposites. But if we went ahead and took out a negative and changed this to negative and that to positive, then this is t minus 1, and it will cancel off with that as long as we have this negative out front. So in the numerator we're left with negative 1, and in the denominator we're left with t plus 1. And that's as simple as we can make it. So there you go. Reduce each of the following rational expressions. Okay, note any restrictions on your variables. So again, factor everything. Numerator, take out a 3x, we're left with x minus 4. Denominator, take out 6, and we're left with x plus 2. And there's not much we can do with this, but the 3 and the 6 will reduce, so we're left with x times x minus 4 over 2 times x plus 2. And of course the restriction on the variable is that x cannot be negative 2, because then the denominator is 0. Oops. X cannot be negative 2. Alright. This one, factor the numerator using sum and product. So this will be plus 4 and minus 1. X plus 4 times x minus 1. You can go ahead and verify that if you want. This is a difference of squares. X plus 4 times x minus 4. Now, looking at your denominator, you can see your non-permissible values right away. X is not allowed to be 4. X is not allowed to be negative 4. Okay, otherwise when it's 4, this is 0, and when it's negative 4, this is 0. And neither of those are allowed. Of course, we can keep simplifying this, and our simplest expression for this is x minus 1 over x minus 4. And you're done. Alright. Let's reduce everything. So let's start with the numerical coefficients. 20 and 12. 4 will come out of both of those. So 4 comes out of 20 to leave us with 5. 4 comes out of 12 to leave us with 3. Those are both prime, so they're not going to reduce anymore. X to the 4 divided by x to the 3 just leaves us with an x on top. Now we have one more y on the bottom than we do on the top. So the y will end up in the denominator, and the difference is 1. So we just end up with a single y. And this is the simplest expression. And of course, from your original equation, x cannot be 0, otherwise the denominator is 0, and y cannot be 0, otherwise the denominator is 0. So the odd thing here is that even in our simplified expression, even though there's no x in it, x still cannot be 0 because it makes our original expression have a denominator of 0. And we don't like it. Okay. Rational expressions with pairs of non-permissible values. What expression represents the non-permissible value for x? Values for x. The expression would be 8x minus 6y cannot be 0. Simplify the rational expression is part B. Okay, so let's take a look at this. If we take out everything that's common, we factor the numerator as a difference of squares, factor the denominator by removing a common 2, this is what we're left with. These pairs cancel because they're the same. And then of course 4x plus 3y over 2 is all that we're left with. And it says x cannot equal 3y over 4. And that comes from this expression, so we're only worried about the denominator for the non-permissible values. So you factor out a 2 and you get 4x minus 3y cannot equal 0. The 2 disappears because it's just 0 divided by 2. 4x cannot equal positive 3y, and x cannot equal 3y divided by 4. And that's where this comes from. Okay. The next part, simplify the rational expression. Oh, we've already done it. It's this right here. The third part, evaluate the expression for x equals 2.6 and y equals 1.2. So they have to give us both values so that we can plug them in. And we just plug them into the original function, and we end up with 7. And let's see what happens if we just plug them into the simplified version of the function. Let's see if we end up getting the same thing. So y is 1.2, x is 2.6, and then divide this whole thing by 2. Okay. So 4 times 2.6 gives you 10.4. It's 10.4 on top, plus 3 times 1.2, come on, is 3.6 divided by 2. 10.4 plus 3.6 is 13.10, also known as 14. All right, divided by 2, and of course 14 divided by 2 is 7, and we get the same answer. So it turns out we can just plug the numbers into the simplified form of our equation or our function rather than plugging it back into the complicated one. So simplifying first, plugging your numbers in after, is going to save you some time. Hit pause, do the OR turn, answers will be here when you get back. There you go. Okay, factor each of these completely. You can do this by now, I think. 9 times 7 is 63, so we go x plus 9 times x minus 7. And you're done. This is a difference of squares, perfect square, difference, and we get 5a plus 7b times 5a minus 7b. So the last one, as you can see here, I took out a factor of 3 and then used the quadratic formula just with easier coefficients. And then the 3 can be factored in again at the end, or you can leave it off like this, but it could be written as 33 plus or minus 3 root 241 over 2. Either way is correct. And since this we can't break down as using our sum and product method, we had to use the quadratic formula. And you all know how to do that, so we'll just skip past it. Alright, reduce each of the following rational expressions. Note any restrictions on the variable. Again, restrictions on the variable only arise because denominator is not allowed to be 0. So, restrictions on the variable, x can't be 7 because that makes the denominator 0, and x can't be 3 because that also makes the denominator 0. Now let's see if we have anything that can cancel. The x plus 7 can't cancel with anything, because if we took a negative out of here, we'd get negative x plus 7, and that's not the same. 7 minus x, though, if we took a negative out of 7 minus x, the x becomes positive, and the 7 becomes negative, and it turns into the negative version of x minus 7. Of course, this has to be multiplied still. And then, since we have the same factor in the numerator and the denominator, that factor can cancel, and we just are left with the negative of x plus 7 divided by x minus 3. And we're done. This one, factoring flowchart, take out a greatest common factor first. And then on your denominator, use your difference of squares, so plus 3 minus 2. So m plus 3 times m minus 2. Restrictions, m can't be minus 3. M, or something like an m, cannot be positive 2. And bang, bang, those cancel off. And we're simply left with 3m over m plus 3. Here, if the denominator can't be 0, then a, b, c, all of these things cannot be 0, because if even one of them is, then your denominator is 0. Negative 18 and 27, and 9 will come out of both of those and leave you with a negative 2 on top and a 3 on the bottom. A over a squared. One of these a's will cancel with one of these a's, and you have more in the denominator, so that's where the a will be left. B squared over b, more in the numerator, so that's where the b will be left. And c over c cubed, this will cancel with one of these, leaving c squared, and more in the denominator, so that's where the c's will be left. What is the ratio of the area of the rectangle A to the area of rectangle B? Okay, so the area is found by multiplying length times width for a rectangle. So this is the area of rectangle A. So the ratio of A to the ratio of B, so A goes on top, B goes on the bottom. B is 9 minus x squared times the same x minus 1. Alright, so restrictions on the variable, let's start with that. X can't be 1, otherwise this dimension is 0, and that doesn't make sense. You don't have a box, or you don't have a square. And this is actually a difference of squares. So in the numerator we have x plus 3 times x minus 1, and in the denominator the 9 minus x squared can turn into 3 minus x times 3 plus x times x minus 1, and of course this gives us two more restrictions on the variable. X can't be 3 and x can't be negative 3, because then we end up with zeros. 3 plus x, same as x plus 3, x minus 1, same as x minus 1. Of course, these aren't subtracting. We don't end up with 0, we're dividing, so anything divided by itself is 1. So we still have 1 on top, even though everything cancels. And then in the denominator we have 3 minus x, and that is it. That's the ratio of area A to area B. The distance d that an object travels can be determined by this formula. We know this from physics. If the distance is represented by x squared plus 7x plus 6 and the speed represented by 4x squared plus 8x plus 4, write an expression for the time. Time equals distance divided by velocity. Distance is given by this, x squared plus 7x plus 6. So that's distance divided by velocity, which is 4x squared plus 8x plus 4. Okay. Now, let's write it in simplest form, it says, and include any non-permissible values. So this will be quick. Let's factor the numerator. X plus 6 times x plus 1. Okay. Sum of 7 and product of 6. And then denominator, take out a factor of 4, and we're left with x squared plus 2x plus 1. Okay, so this will be x plus 1 times x plus 1. Alright, so this is going to cancel with that. But our restrictions on the variable, x is not allowed to be negative 1, and that's it. Because these factors are identical. And then, of course, our simplified form is x plus 6 over 4 times x plus 1. And we're done. If the time taken on the trip is half an hour, 0.5 hours, determine the speed of the object and the distance traveled. So, time is given by this expression. Now, we are given the time here, so we plug in 0.5 into this, equals x plus 6 over 4 times x plus 1. So the time taken on the trip, determine the speed of the object and the distance traveled. So this involves solving for our variable x. So we multiply this over here, and we get 2 times x plus 1 equals x plus 6, and 2x plus 2 equals x plus 6. Subtract x from both sides, subtract 2 from both sides, and we get x equals 4. Now this is not our final answer because x doesn't actually give us a speed or a distance. These formulas here give us the speed and distance. So now we just have to plug our known value of x into them and we'll have our answers. So for the first one, the distance here, we now go 4 squared plus 7 times 4 plus 6. So this is 16 plus 28 plus 6, 16 and 34, and our distance is 50. And of course they don't give us units, so we'll just leave it as 50 units. And the speed is 4 times 4 squared plus 8 times 4 plus 4. So we get 4 times 16, which is 64, plus 8 times 4, which is 32, plus 4. 64 and 32 is 96, plus 4 is exactly 100. There you go. So it makes sense. Travel, let's say, 100 kilometers an hour for half an hour, and you travel 50 kilometers. It all adds up. And that's it for today's lesson. See you in class tomorrow.